Hi everyone, this is Research Methods in Nutrition 3. We will be looking at statistical principles for nutrition research. My name is Dr. Jumoke Georgina Ilo. The outline, we'll be looking at the basic statistical concepts, the types of data in human nutrition, descriptive statistics, inferential statistics in human nutrition, and lastly, choosing the right statistical test. Statistics provide the foundation for analyzing, interpreting, and communicating findings in human nutrition research. However, without proper statistical understanding, research results may be misinterpreted or misleading. We will be looking at the basic statistical concepts. There are different types of variables. We have the independent variables, dependent variables, confounding variables, and the control variables. Dependent variable describe the factors that might influence the outcome, while dependent variable describe the measured result or effects. For example, when you have a diet, a high or a low fiber diet, and then you want to look at the effects of consumption of this diet on the blood cholesterol level. That diet you are introducing is a factor that might influence the outcome, and the measured result is the blood cholesterol. So the factors that might influence the outcome, which is the type of diet, high fiber or low fiber, as an example, is the independent variable. While the dependent variable is the measured result or the effect you are expecting or looking into, which is the blood cholesterol level. There are also some variables that can affect both independent and dependent variables. It could be the age, it could be physical activities, it could be the socioeconomic status. And most times when they are not handled, they could give a misleading result. This is called the confounding variables. And in a case or in a way to address or cater for confounding variables, there might be need for us to control our variables. You want to look at the effect of consumption of high fiber on the blood cholesterol level of a population. The age is a determinant that can give a misleading result. Then you choose to stay within the age of 18 to 25 for adults. That is a controlled variable. Let's look at population and sample. Population is the total group the researcher wants to make conclusion about. You want to make a conclusion about all pregnant women in Ogun State or in Oyo State or in Africa, in Nigeria, in Sub-Saharan Africa, or you want to make a conclusion on children under 5 age in Southwest Nigeria, in the whole of Nigeria, in Africa, and the likes. That is the population. Your sample is now the subset of the population selected for the study because it is less expensive when you make use of sample rather than the population, because it is quicker to make to address or make a conclusion on 300 pregnant women rather than the whole pregnant women in Oyo State, because it is easier to manage, and most importantly, it gives a valid conclusion, that is a true representation of the population. This is your sample. It describes as the subset of the population selected for that study, and it is a true representation of that population. Types of data. We have nominal data. Nominal data are categories without any order. We are looking at the sex, the male or female, the types of meal, that breakfast, lunch, or dinner. The ordinal data is the categories with a clear order, but difference are not uniform. For example, nutrition knowledge level. It could be low, medium, high. We are looking at a nutrition knowledge level point question of 30 points. 0 to 10 could be low, 11 to 20 could be medium, while 21 to 30 could be high. And for the same nutritional knowledge level, you could have a 15-point question where 0 to 5 is medium, is low, 6 to 10 is medium, and 11 to 15 is high. So it is in categories, categorical, which is it is having a clear order, but differences are not what they are not uniform. And we have the interval data, where numerical data with equal intervals but no true zero. Example is simple, like we have in the temperature in Celsius, in degree Celsius, or standardized nutritional knowledge test score. Then for the ratio data, numerical data with equal interval and a true zero. A good example is the body mass index, where you measure obesity as above 25 kilogram per meter square, and you take overweight rather as 25 kilogram per meter square, and obese as over 30 kilogram per meters square. Descriptive statistics. Descriptive statistics summarizes and describes the basic feature of data. You want to summarize and describe the basic features, just the basic feature of a data. It helps us to understand the central tendency and variability. Number one on the list is the mean, which is also the average. For mean, you add all the numbers and divide it with the number of observation. For example, when you want to find the mean of the the consumption of iron in grams for 5 children, and you have your figures as 8, 10, 12, 10, and 14. You sum up all together and you divide by the number of observation, which is 5. For mean, it is usually use it for data that are normally distributed. That is, they are not skewed data, they are not having any outliners. Outliners means you have a 10, a 8, a 12, a 14, a 10 again, and then you are having a 40, you know. So in such an instance, cannot use it is not possible to find mean. And when we have outliners, then or when the data are skewed, then you could be looking at the media, which is the mid value, where you arrange in a particular order, whether descending or ascending. And it's best used when data are skewed and when they are when we have outliners. The mode the mode is the most frequent value, and majorly for categorical data. The standard deviation, this indicates how spread out data is around the mean. You already know your mean. You now want to know how spread around that mean at my data. Then standard deviation will give you um, a picture of that. For example, your mean vitamin C intake of the data is 70, and your standard deviation is 3 milligram, or 3 is the 3 milligram. Then you are looking at subtracting 3 from 70 and adding 3 to 70. So you can say confidently that 67 to 73 milligram of vitamin C are what are being consumed by your population. Another one is the variance. Variance is the square of standard deviation, and it shows how much data points differs from the mean mathematically. Inferential statistics. Inferential statistics allow researchers to make conclusion about the population based on the sample data. It answers questions like, is there a significant difference between group? You want to know if two variables are related. You want to know if if the nutrition intervention actually work, at their impact effect, for this inferential statistics is very important. Unlike descriptive that will give you the frequency, the percentage, the prevalence, inferential will let you to understand the reason why you are having a particular result. It's concluding about the population based on the sample data. Then you can tell if there is a significant difference between groups or not. The first on list is the t-test. T-test is used to compare the means of two groups. When you want to find the means, want to compare the means, the mean, that is the average of two groups, then the t-test is the best to use. There are different types. When you are comparing mean of two different groups, the groups are different, maybe a male and a female group, maybe a group and a B group, and you use independent t-test. But when you are comparing the same group, you are looking at a before and a after comparison of the same group after an intervention, then a pair t-test will be used. For chi-square test, we are looking at relationship between categorical data. Yeah, that is, you want to know if there's a relationship between skipping breakfast and the sex, the gender. The gender is a male or female. The skipping of breakfast is either you skip or you don't skip, it's either a yes or no. So they are categorical data and you want to find the relationship. Chi-square is best used. When you want to look at relationship between continuous variables, you want to look at the relationship between continuous variables such as the food intake and the BMI value, the person blood sugar level and sugar intake, then you can look at correlation. Then if you're now looking at relationship or comparing three or more groups, then ANOVA is what is expected of you to be. In summary, choosing the right statistical data depends on the type of data, the number of groups being compared, and the study design. For type of data, if it is categorical, you know that you are taking chi-square. If it is continuous, then you know that it is either t-test, either ANOVA or correlation. Then if for number of groups being compared, if you are looking at two groups, you know that the likes of t-test will be used. And if you are looking at three or more groups, the likes of ANOVA will be used. And lastly, if you are looking at study design, you are you doing a before and after, a pre and post test on the same population, on the same sample, then a pair test will be used. If you are looking at two different groups entirely, then independent t-test will be used. Then if you are looking at relationship between continuous variables, the correlation will be used. At this junction, it is good to say thank you for listening, and my next video will be looking at investigation methods in human nutrition. Thank you and bye for now.